So let's talk for a few minutes or reflect about what a graph or network is in mathematical terms. So the theoretical definition of a graph, as in graph theory, is a set of nodes or vertices and edges or links that connect the vertices or nodes. So the common visual representation is to use circles for the vertices or nodes, and it's also very common to label them. So I'm going to use some simple label. We could use letters, or we could use integers. So if we were using integers and write labels like 1, 2, 3, 4, 5, and 6 for the vertices or indices, so we could say, okay, there is a set of vertices. We could use the letter V to denote this set of vertices. So here, that's what I mean. This is V, a set of vertices. And then we can define the edges. Right now, visually, there is no edges. It's very common to use simple segment, like a linear, just like a little line there, to denote that there is an edge or a so-called link between certain nodes. So I'm gonna do this completely define this is completely about what defines an edge between two vertices or two nodes. It may be a friendship, it may be a business relationship, it may be a route for transportation. Those are the common scenarios that would be used to map a situation into what we know as a theoretical graph. So these edges or links that I am drawing here are completely arbitrary. This is the graph that I'm using to illustrate what the edges would be. So once we have defined what the labels are for each, the labels or tags for each vertex or node, what they are, then we can store information about an edge is a connection between two nodes or vertices. And a common way of denoting that connection is with parentheses. So there is an edge between 1 and 2, and so we denote as a pair 1, 2. That is the common notation for that edge or link. So in this case, the graph that I'm illustrating here, the edges do not have arrows. There is not a sense of direction. This is what formally is called an undirected graph. So just in simple terms, if there was a sense of direction, then the graph would be called directed. So the edges would have an arrow and there wouldn't be redundancies. So right now, an edge between 1 and 2 is the same as an edge between 2 and 1. So we only write one pair. And so here, and the set E is collecting the so-called edges or links, and we use that notation. So here, in general terms, we would write something like G, the graph, is basically the set of vertices together with the set of edges, right? This is what we would call a graph in graph theory terms, or it may also be called a network. So in this context, there is some common vocabulary. We're going to say that a node represents one of those circles that we were illustrating before with either an integer or a character. So a node, another name for node is also vertex. A link may also be known as an edge. So nodes and links are the terminology we would use for the internet. Usually a web page is represented with a node, and a link is one node connected to another node, one web page linking or connecting to another web page. Degree here, you could have, if there are arrows in the graph or the network, so you may have incoming degree, outgoing degree, but for undirected graphs, networks where there are no arrows, the degree simply is based on the number of links, okay, or the number of edges that one node or vertex has. And so the direction, there may be a sense of direction. This is what we're mentioning, that there are undirected, there are some that are called undirected graphs, and there are other ones that are called directed graphs. So there may be a sense of how one would traverse or travel throughout this set of nodes and links. There is a family of graphs that are called trees, and they have a sense of direction. In other words, we would travel through the vertices starting at the top and moving down, right? So there would be a sense of having one vertex. Here the vertices, I'm using letters, characters in uppercase instead of positive integers. So we start at A, and we may go into B. There is also a link or an edge connecting A and C. And then from B, this connects to a vertex called X, and B also is connected to a vertex called D. So the other characteristic here is that the degree, number of edges or links from a given node, does not exceed, is at most 3. It may be 1, or it may be 2, or it may be 3, but it doesn't exceed. The nodes do not have more than 3 links or connections. Because there is a sense of direction, everything begins at a vertex called root, and then the vertices or nodes where that are in the periphery or at the end of the cascade, they're called leaves. So there is a root vertex or root node, and there are nodes that are considered leaves.